Hi, 7th grade. Today is Thursday's lesson, and today we'll be doing lesson 1.4, which is scaling up prisms, and this you'll find on page 13 of your book. Okay? Our gotta checks today are going to be a Mrs. Pileggi gotta check, which means that you won't find it in your book, you'll only find it on the video. So you'll have to kind of watch and pay attention for the gotta check towards the end of this video. Your homework today is page 17, number 8, and your bell ringer today is page 20, number 17. Okay, let's talk about how scale factor can change the dimensions and the volume of an object. So we're going to be looking at two separate entities. So what I want you to do is we're going to draw a line kind of down the center, and we're going to look at how scale factor changes dimensions and how scale factor can change volume. Okay, so here's what we're going to start with. Okay, for both cases, we're going to start with a very simple box that is called a 1, 2, 3 box. So I'm going to draw this guy in. Okay, it's called a 1, 2, 3 because its dimensions are 1, 2, and 3. Okay, so in both cases, my little 1, 2, 3 box is going to have a volume of 6 cubic units, right? Okay, so we're starting with a volume of 6 cubic units. Okay. First of all, we're going to look at how scale factor can change when you take a scale factor of volume, how that will change dimensions. Okay, so our first example is I would like to double the volume of this box. Okay, if I double the volume of the box, what would my new volume be? Well, double means multiplied by 2. So my old volume was 6. So I'm going to take 6 times 2 equals 12. So I want my new volume of the box to be 12 cubic units. Okay? Well, let's think about the box. Okay? What would we have to do to double the volume of this box? Well, if you think about it, we could take this box and sit a similar box right next to it, right? That would be 2 boxes that would make 2 of the volume. We could sit another box on top of it. That would be 2 boxes that would give us double the volume. And when we double the volume, and I'm going to kind of try to draw the picture of this that explains it. So what I've decided to do is I've decided to stick 2 boxes right next to each other. So this is my 3 by 2 by 1 box, and I've just stuck another 3 by 2 by 1 box next to it. Okay? But what we can see is the height and the length haven't changed. The only thing I had to do to double the volume of the box was I had to double or multiply by 2 one dimension. Okay? So if I want to double the volume, I only need to double 1 dimension of the box. Okay, so let's try the gotta check. Okay, so your Mrs. Pileggi gotta check is going to be, let's say I'm back to starting with my 1, 2, 3 box, or my 3, 2, 1 box, however you want to call it. What if I want to triple the volume? If I want to triple the volume, what would I have to do to the dimensions? Okay, pause the video right there. Come back when you're ready. All right, let's take a look at the gotta check. Okay, so remember, when I wanted to double the box, all I had to do was put 1 right on the side of it. So if I want to triple the volume, well, I should have 3 boxes lined up. So all I should need to do is I should need to triple 1 dimension. So that means that as long as I tripled the length. Okay, so I could triple the length to 9 and leave the other two dimensions the same. That would give me a box that is triple the volume. Okay, hope that makes sense. All right, now it's time to look at the other side of the box. Okay, so how does changing the scale factor of a box change the volume? Okay, so this time, again, I'm going to start with a 3, 2, 1 box. Okay, but this time I'm going to apply my scale factor to the dimensions. Okay, so this time I'm going to increase the dimensions by a scale factor, and I'm going to abbreviate that SF, of 2. Okay, so I'm doubling the dimensions. Okay, well, if I double the dimensions, let's think about what my new box will look like. My new box will be relatively the same shape, but it's going to be 2 times bigger on every side. So instead of being 3 here, it's going to be 6. Instead of being 2 here, it's going to be doubled, 4. And instead of 1, it's going to be doubled to 2. Okay, so what is my new volume? Well, my new volume is 6 times 4, which is 24, times 2, which is 48 square units. That is a lot bigger than this one. In fact, changing the scale factor of 2 meant that this is actually 8 times bigger, right? Because 6 times 8 equals 48. So my new volume is 8 times larger. And where does that come from? Well, remember way back in scale factor, when we talked about if you change the scale factor of the dimensions of figure, your area would be squared? Well, let's think about volume. I just realized I made an error here. Volume is not in square units, it's in cubic units. So what that means is when I multiply, it's multiplied by my scale factor cubed. So if my scale factor was 2, 2 to the third power, or 2 cubed, is 8. And that means my volume is going to be 8 times larger. All right, so it's time for your Mrs. Pileggi Gotta Check number 2. So your Gotta Check number 2 is going to be, what if instead of increasing the dimensions by a scale factor of 2, I increase the dimensions by a scale factor of 3? So that means I'm going to triple the dimensions. What would my new volume be now? So if I increase by a scale factor of 3, what would my new volume be? All right, I hope you've come back from the pause of the video, and let's find out what my new volume would be, okay? So this time, I'm working with a scale factor of 3. So what that means is I'm going to increase the volume by 3 to the third power, because 3 is my scale factor. So I have to increase my volume. It's going to be 27 times larger. That's pretty big. So let's see what that turns out to be. My original volume was 6. If I multiply that by 27, because that is the scale factor cubed, my new volume is going to be 162 cubic units. That, my friends, is pretty large. Okay? But that is scale factor, and that is how scale factor, scaling volume can change dimension, and it's also how scaling dimension has a big effect on our volume.